Hey guys, this is Professor Janacek, and I want to review extrema and inflection points. Let's begin with the first derivative. It gives us some information about increasing and decreasing. If the first derivative is negative, then our function is decreasing, and if the first derivative is positive, then our function is increasing. The first derivative can also give us our possible extrema. If the first derivative is equal to 0 or undefined, then we have a possible maximum or minimum, possible extrema. We do call these the critical values. You could call them critical numbers or even critical points because they are technically points on the x-axis. Now the second derivative tells us about concavity. If the second derivative is negative, then our function is concave down. And if our second derivative is positive, then our function is concave up. The second derivative also tells us about possible inflection points. If the second derivative is equal to 0 or undefined, then we have a possible point of inflection. Now on to our derivative tests. The first derivative test for extrema. Now we start by finding possible extrema, in other words, finding those critical values. Then we simply look to the left and to the right of that possible extrema. If to the left it's decreasing, meaning the first derivative is negative, and to the right the function is increasing, meaning the first derivative is positive, then you see we have a minimum. Now, if to the left our function is increasing, meaning the first derivative is positive, and to the right our function is decreasing, meaning the first derivative is negative, then we have a local maximum. We also have a second derivative test for extrema. Since the second derivative gives us concavity, we can use that to determine our extrema. If f is concave up, meaning the first derivative is positive, the second derivative is positive, concave up, second derivative is positive, then we would have a minimum. And if the second derivative is negative, meaning it's concave down, then we would have a local maximum. Do be aware that if the second derivative is equal to 0, that doesn't tell us anything about our function. We also have a second derivative test for points of inflection. Again, we would have to start with a possible inflection point. But then if our function is concave down on the left, meaning the second derivative is negative, so concave down on the left, and concave up on the right, meaning that the second derivative is positive to the right, then we would have an inflection point. Or if our function is concave up on the left, meaning the second derivative is positive, and it's concave down on the right, meaning the second derivative is negative, that would also give us an inflection point. There is also a third derivative test for inflection points. This one is fantastic. Again, we start with a possible inflection point, but if things got moved around. If the third derivative is not equal to 0, then we have an inflection point. But be aware that if the third derivative is equal to 0, our test is inconclusive. That gives us no information. It's only if that third derivative is not equal to 0, then we have an inflection point. Well, there you go. Hope you enjoyed.